In this lecture video, I will show you how to solve hypergeometric differential equation. Let's start. Let's trial solution of the equation. Y is equal to k x to the power p plus k, where p and k also constant and integer. Then y prime means first derivative of y with respect to x is summation k ak p plus k x to the power p plus k minus 1. If we take derivative of x to the power p plus k, then we get p plus k x to the power p plus k minus 1. And if we take second time derivatives of y with respect to x, then we get d2y dx2, and this is double prime is equal to summation k ak p plus k into p plus k minus 1 x to the power p plus k minus 2. Now if we plug this value y prime and y double prime in equation 1, then we get plugging the value of y prime and y double prime, then we get x into x minus 1 y double prime means summation k ak p plus k minus 1 x to the power p plus k minus 2, then plus here right plus 1 plus a plus b plus x minus c summation k, then y prime, the value of y prime ak p plus k x to the power p plus k minus 1, and then another plus a b y, the value of y is equal to k ak x to the power p plus k equal to 0. Now if we minus x is equal to k ak p plus k minus 1 x to the power p plus k minus 2, plus if we multiply this with this and this, then we get 1 plus a plus b into k ak p plus k x to the power p plus k. If we multiply this with this, then this x will be multiplied with this, then we get x to the power p plus k minus 1 plus 1, then minus 1 and plus 1 will be cancelled out, so we get ak into p plus k x to the power p plus k, that is, and we get, and if we multiply this with this, then we get c k ak p plus k x to the power p plus k minus 1, and last this term it a into b into summation k ak x to the power p plus k is equal to 0. Then if we solve this, then if we multiply this term with x square, then we get k ak p plus k x to the power p plus k. If we multiply x square with this term, then these two add with p plus k minus 2 plus 2, then minus 2 plus 2 will be cancelled out, so we get x to the power p plus k, and minus, if we multiply this with this x, then we get k ak p plus k minus 1 and x to the power p plus k minus 1. If we multiply x with x to the power p plus k minus 2, then we get x to the power p plus k minus 1 and plus 1 plus a plus b k ak p plus k x to the power p plus k minus this term c k ak p plus k x to the power p plus k minus 1 plus ab k ak x to the power p plus k is equal to 1 0. Let's another page. Therefore we may write here the coefficient of x to the power p plus k, and here coefficient of x to the power p plus k, and here also x to the power p plus k. So these three terms we will be write together, then we get k ak. Every term has ak, then we can take common ak p plus k and p plus k minus 1 from this term, and the second term from the second term plus b, okay, and this p plus k, okay, and also this term plus ab x to the power p plus k, then this term and this term, and let's this term and this term. Here also ak will be common out, ak, and also p plus k common out, then p plus k minus 1 and this minus, but we already take common minus, then there will be plus c, okay, and x to the power p plus k minus 1 is equal to 0. Therefore if we do calculation sum, then we will get p plus k plus a plus b plus ab x to the power p plus k. If we calculate this, then we will get this term minus k ak p plus k and p plus k plus c minus 1 into x to the power p plus k minus 1 is equal to 0. Then k ak, from this term, if we multiply this with this and with this, then we get p plus k the whole square plus p plus k, and this p plus k will be p plus k the whole square plus p plus k into a plus b, p plus k into a plus b plus ab, okay, x to the power p plus k and minus k ak p plus k p plus k plus c minus 1 into x to the power p plus k minus 1 is equal to 0. Therefore, we can write k and p plus k plus a into p plus k plus b x to the power p plus k minus k a k p plus k and p plus k plus c minus 1 to the power x to the power p plus k minus 1 equal to 0. Okay, then we get this equation here. This here coefficient of x to the power p plus k is this, and coefficient of p plus k minus 1 is ak p plus k plus c minus 1. Here we do now equating the coefficient. Now equating the coefficient of the lowest lowest power of x. Here we take the coefficient of lowest power x, means x to the power p plus k minus 1. This is the lowest power of x, and this coefficient of x to the power p plus k minus 1 is ak p plus k plus c minus 1 is 0. Means here we take x to the power p plus k minus 1, its coefficient is 0, and also k equal to 0. Then we can write a0 p plus 0 plus c minus 1 is equal to 0. Because of coefficient of lowest power of x is 0, means this coefficient is 0, and here a not equal to 0. Therefore we can write p plus c minus 1 is equal to 0. Here we get two root of p. One is p equal to 0 and p plus c minus 1 equal to 0. Therefore p is equal to 1 minus c. Here we get two value of p. One is p equal to 0 and another one is 1 minus c. This value of p we need sometime after. So then we will be calculate this term also. Now k p plus k plus a and p plus k plus b x to the power p plus k and k p plus k plus c minus 1 into x to the power p plus k minus 1 0. Therefore here we take x to the power p plus k for this total term. So here already x to the power p plus k, then and here p plus k minus 1. So to get p plus k we put k plus 1 is equal to k. So p plus k plus 1 minus 1 is equal to 0. Therefore p plus k, we get p plus k. So here we can write, here is a forget about that. ak and p plus k plus a, p plus k plus b, x to the power p plus k. And from second term we can write, here we take k plus 1 to get x to the power p plus k, then a k plus 1, here also p plus k plus 1, and here p plus k plus 1 minus c minus 1 into x to the power p plus k plus 1 minus 1 is equal to 0. Therefore we can write k ak p plus k plus a, p plus k plus b, x to the power p plus k minus k plus 1 p plus k plus 1 and p plus k plus c, plus 1 minus 1 will be cancelled out, into x to the power p plus k is equal to 0. This is k, only k. Therefore we can write k here ak p plus k plus a, p plus k plus b from first term, and from second term minus a k plus 1 p k plus 1 p k plus c whole x to the power p plus k equal to 0. Therefore now we get this term. Let's another page. Here this is the equation. Now equating the coefficient of x to the power p plus k equal to 0. Now the equating the coefficient of x to the power is 0. Therefore here we take coefficient of x to the power p plus k is 0, so ak p plus k plus a and p plus k plus b minus a k plus 1 p plus k plus 1 p plus k plus c is equal to 0. Therefore ak p plus k plus a, p plus k plus b is equal to ak plus 1 p plus k plus 1 p plus k plus c. Therefore we can write ak plus 1 into p plus k plus 1 p plus k plus c p plus k plus a p plus k plus b ak. Therefore ak plus 1 is equal to, this term will be divided, therefore p plus k plus a p plus k plus b divided by p plus k plus 1 and p plus k plus c, and here ak. We get one equation of ak plus 1 and ak. Now previously we get two value of p, one is p equal to 0 and another one 1 minus c. Now here we put p equal to 0. When p equal to 0, therefore put p equal to 0 in this equation, so we get ak plus 1 is equal to p0 means k plus a into k plus b divided by here also p equal to 0, তাহলে k plus 1 k plus c ak. Okay, now we find a1 a2 a3 and also an. So put k equal to 0 in this equation, so we get a1 is equal to, then k equal to 0 k equal to 0, so we get a dot b divided by 1 into c and a naught. This is the relation between a1 and a naught. Similarly, if we put k equal to 1 in this equation, so we get a2 is equal to 1 plus a 1 plus b divided by 2 to 1 plus c a1. If we put the value of a1, so we get the value of a2 in terms of a naught, so 1 plus a and a. Similarly, b a plus b divided by 2 dot 1 and c dot 1 plus c, and here a naught a2. Similarly, if we put k is equal to n, now k equal to 3, then k equal to 2. If we put k equal to 2, then we get a3 into a3 will be a into 1 plus a into 2 plus a, b into 1 plus b 2 plus b divided by 3 into 2 into 1 c into 1 plus c into 2 plus c, and here we get a naught. So if we take k equal to n, then we get an equal to, if we pay an plus 1 is equal to, no, if we put k equal to n minus 1, then we get an is equal to a into 1 plus a into 2 plus a to dot 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 a plus n minus 1 and b 1 plus b 1 plus 2 plus b dot 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 b plus n minus 1 divided by here 3 to 1, so we get here n minus 1 dot 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 3 to 1, and here we get c 1 plus c 2 plus c c plus k minus 1 and a naught. Therefore, at k equal to n minus 1, an is equal to a into 1 plus a 2 plus a dot 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 a plus k minus 1 and b into 1 plus b 2 plus b dot 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 b plus k minus 1 divided by n factorial, this is n factorial, and c into 1 plus c 2 plus c c plus k minus 1 and an. Okay, let's another page. So while p equal to 0, then previously we take a trial solution of this equation, that is that was y equal to ak x to the power p plus k. So when p equal to 0, then we get ak x to the power k. Therefore y is equal to k ak x to the power 0 plus k. Therefore we can write k ak x to the power k. So y is equal to, if we expand this series, so we get a naught x naught plus a1 x1 plus a2 x square plus dot 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 plus an x to the power n. Therefore if we put the value of a1 a2 a3 from this relation, so we get a naught x2 means 1, so a1 x plus a2 x square plus a3 x cube plus an x n. Okay, then a naught plus a1 means a into b divided by 1 by c. So from a into b by 1 into c, a naught x plus a2 means 1 plus a 1 plus b divided by 2 factorial 1 plus c x square plus, if we put the value of a3, then this will be a into 1 plus a 2 plus a into b into 1 plus b into 2 plus b divided by 3 factorial c into 1 plus c 2 plus c into here a naught and also x cube plus dot 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 plus, if we take n terms, then we will get what we will get plus this term will be dot 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 up to infinity. So if we take common a naught from all these terms, so we get a naught bracket 1 plus b 1 factorial c x plus here will be a and b, then a into 1 plus a b into 1 plus b divided by 2 factorial, here also c, then c 1 plus c x square plus up to infinity, then a naught. If we write this value in terms of series, in terms of summation, so we will get a naught k equal to 0 to infinity a 1 plus a 2 plus a up to a plus k minus 1 to b 1 plus b 2 plus b dot 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 up to a plus k minus 1 b plus k minus 1 divided by n factorial k factorial, because here we represent k, so k factorial, and c into 1 plus c 2 plus c, then c plus k minus 1. Okay, to get simplify of summation equation, here we use Pachama symbol. What is Pachama symbol? Let's see here. Pachama symbol, what is Pachama symbol? Pachama symbol is represent as ak equal to, here we take a, here a 1 plus a 2 plus a plus k minus 1. So if we here a plus 1 means 1 add with a, here 2 add with a, similarly here a minus, here k minus 1 add with a. So if we take 1, if we multiply with a 2 1 2 3 4 dot 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 a minus up to a minus 1, which is less than a, that is a minus 1. So 1 2 3 4 a minus 1, and this term 1 2 plus a plus k minus 1. We taking this term and this term will be cancelled out, so this is will be 1 and 1 is multiplied with 1 this, so we get this term. So here 1 2 3 4 and up to a plus k minus 1 and a minus 1, then if we add with a minus 1 then we get a, if we add with a then we get a plus a. So this is, so this term we can write a plus k minus 1 the factorial, a plus k minus 1 factorial divided by this can be written as a minus 1 factorial. Okay, this is called Pachama symbol. So similarly we can write for b, because here bk is equal to b 1 plus b 2 plus b up to b plus k minus 1. So this is also can also be written as b plus k minus 1 factorial, b minus 1 factorial. Similarly for c plus k minus 1 factorial divided by c minus 1 factorial. So now this equation can be written as y, this equation can be written as y is equal to a naught 0 to infinity. This term we get ak and bk, because of a into a plus 1 into a plus 2 up to a plus k minus 1 means ak bk, and this term ck, ak bk ck wherever k factorial, so k factorial and ck. Okay, and here we get, sorry, there will be x to the power k, because of this series can be written as this k. Okay, so this is one solution for the when equal to 0. So this is y1. Previously solving few steps, we get this term, and after that we will put p equal to 0 here. Now we put p is equal to 1, p is equal while is equal to 1 in this equation. Sorry, 1 minus c, because we get previously we get p, one solution of p is 0 and another solution is 1 minus c. So here we put p equal to 1 minus c, so we get a k plus 1 1 minus c plus k plus a 1 minus c plus k plus b divided by 1 minus c plus k plus 1 and 1 minus c plus k plus c into ak. So we can write so this term will be k minus c plus a plus 1 and this term will be k minus c plus b plus 1 divided by k minus c plus 2 and this term will be k plus 1 to ak. This is a, so plus 1 a minus c plus 1 plus k and b minus c plus k plus 1 divided by k plus 1 into k minus c plus 2 into ak. Okay, here if we put a prime is equal to a minus c plus 1 this term, and b prime is equal to b minus c plus 1 b prime, and c prime is equal to if we put 2 minus c then we can write a k plus 1 is equal to this term will be a prime plus k and this term will be b prime plus k divided by k plus 1 into c prime plus k and ak. This is, so this term is similar with this term here a and here a prime b prime c and c prime. So similarly if we calculate a1 a2 a3 similarly an, so we get this term also, and therefore if we put k equal to 0 then we get a1 is equal to a prime b prime 1 into c prime a naught. Similarly for a2 is equal to a into 1 plus a prime 1 plus a prime b prime 1 plus b prime divided by 2 factorial into c prime plus 1 into a naught. Similarly for an we get a prime 1 plus a prime 2 plus a prime n minus 1 plus a prime b prime 1 plus b prime, similarly n minus 1 plus b prime divided by get here n prime and c prime plus 1 c prime plus k minus 1. Similarly if so while p is equal to 1 minus c, then y2 is equal to k ak x to the power p plus k. So k ak x to the power 1 minus c plus k. So if you can write k ak x to the power 1 minus c into x to the power k. So we can write y2 is equal to k ak x to the power k, and this term will be common out 1 minus c. So we can write x to the power 1 minus c a naught a x naught plus a1x plus a2x square plus a3x cube up to infinity. So if we put a1 put the value of a1 a2 a3, so we get 1 minus x to the power 1 minus c, and this term will be here a not common out, and k here will be a prime k b prime k, in fact k factorial c prime k. This is here all step will be similar to the previous when we put a p equal to 0. So equal to a naught x to the power 1 minus c k a prime k b prime k k factorial c prime k. So therefore the solution of the hypergeometric differential equation will be y is equal to some constant a y1 plus some constant b y2. So y is equal to y1 means x plus b into a naught means b, and x to the power 1 minus c f of 2 1 a prime b prime c prime x. So this is the solution of hypergeometric differential equation. Here some property for hypergeometric differential equation will be discussed, this property of hypergeometric differential equation later. So this is for today. Thank you for watching the video.